All right, class, the purpose of this video is to walk you through 4 problems. So I'll have the page number, it's page 122 up here, and it's the try it problems. And what I really suggest is you try the problem, read it over by yourself, and see if you can just do it on your own. And then I'll walk you through it if you don't. Anyway, this is just going to be a resource for you. So the first problem is there is a graph that represents the rate at which Marlo makes origami birds for a craft fair. And then it says the equation y equals 2.5x represents the number of birds y that Josh makes in X minutes. And the hard part about this problem is they give you 2 guys, right? They give you Marlo in a graph, right? And then they give you Josh, but they give you an equation. So Josh has y equals 2.5x, where x is the time, so like time, and y is the number of birds. And it's really hard to compare these because one's in words and one's in a graph. Now what we can do is we can find the rate that they made the birds from the graph or the equation and compare the rates. So let's look at let's look at Josh first. Well, if he does 2.5x, that means if he works for 1 minute, that means he makes 2.5 birds, right? And that would mean also if he worked at 2 minutes, that makes 5 birds, right? So, but his rate is actually just the 2.5 over 1. So he makes 2.5 birds per minute, okay? So like he's halfway through the 3rd bird when he's on the minute. And then if you look at Marlo, it has a graph, and I'll just show you some. Right here it has 20, 40 here, and then it just comes up to 4. So his is, he has a point here at 20, no, it looks like 10, 20. So a point at 10, 2, and he has another point here at 24. So you don't really see a number that he gets, but you know that at 10 minutes, right, he had 2 birds, right? And at 20 minutes, he had 4 birds. So you have to think, how many birds is he making per minute? Well, what I see from here is that it was 10-minute difference. In 10 minutes, he had 2 more birds. So I would say in 10 minutes, he had 2 more birds. So that is 2 birds per 10 minutes. Let me make sure you guys can see that. 2 birds per 10 minutes. Well, that doesn't actually seem very good to me, because if 2 birds per 10 minutes, that means 1 bird in 5 minutes. So how many is that per 1 minute? Well, then you just have to make it a decimal. 1 divided by 5 is 0.2 over 1. Whoops, 0.2 over 1. So I don't think that's very good. So in 1 minute, he makes 0.2 birds, right? So he's slower. I think he's slower. So if he's slower, then that makes Josh faster. Okay, and that would be how you answered that. But the important part is we figure out how to compare the rate. Just a disclaimer, if I make any mistakes on these, I will give you extra credit if you catch them, okay? You only know that if you watch this video. Okay, let's look at page 123. This is a high-speed train. So it says, and again, they give us some data in a graph and some is not in a graph right here. Oops, let me put it right here. Okay, so the fastest high-speed train in Japan, so we'll write Japan here, is represented in the graph. And the fastest high-speed train in the US covers so we'll put US over here, USA. It is 600 kilometers in 1.5 hours. So we're really going to want kilometers per 1 hour. So we'll have to fix that in. Oh, no, sorry, 2.5. The problem says 2.5 hours. We're going to definitely want to know what that is in just hours. And over here, it gives us a couple points. And it looks like I have right here is at 1 hour. And this point is about, looks like 350. And this one, it has a point here at 2 hours. And it looks like, I would say 640. Okay? And it gives another point too. And actually, that one's easier. It's in 3 hours, it goes 1,000 miles. All right. So maybe you only know how far it went after a certain amount of time and you didn't actually make an equation. All right. So what I need to do is figure out how fast it is. Now this is a straight line, which means this speed is constant. Okay. So it's not speeding up or slowing down. They probably cut off those ends there. So to do this, we need to find out what is their speed in just kilometers per hour. So if I have 600 kilometers in 2.5 hours, I can actually, on my calculator, do 600 divided by 2.5, and it'll give me how many in 1 hour. So let me do that. Get a calculator. Get your calculator out, or Google it, or whatever you need to do. So my calculator. Oh, calculator doesn't work. Bummer. 600 divided by 2.5. Probably do this in your head faster than I can do it on the calculator. $600 divided by 2.5 equals 240. I got 240. So that means the USA went 240 kilometers in 1 hour, because 240 over 1 is the same as 640 over 2. Sorry about the glare there. All right, now we have to figure out this guy. And this one's a little bit harder, I think, because you're not really sure what to do. So let's look at this. I'm going to look at this point here and this point here. From here to here was 2 hours. So I went 2 hours total from here to from this point to this point. So 2 hours. So in 2 hours, I went, how many miles? Well, I have 350 and 1,000, so that's 750. So I can just say 1,000 minus 350. Is that 750? No, that's 650. So that's 650 kilometers in 2 hours. This is pretty close. So let's see what it is. 650 divided by 2, get 325. So I get 325 kilometers per hour. So who's faster, Japan or US? In this case, I would say definitely Japan has a faster train than the US. Okay. Let's see. We have to go to page 128. Okay, here we go. Over here. Okay, 128. All right. This one says, Jack graphs how far he plans to bike over a 3-day charity ride. Find the slope of the line. So what it does is it gives you a couple days, and he's planning out his days, and it gives you some points. So right here has, at 1, he has 30. You have to kind of figure this out from looking at the graph. At 2, he has 60. And at 3 days, he's gone 90 miles. All right. And they actually point out 2 points here. And remember, when we have points, we can label them as, right here would be 2, 60. And this is 3, 90. Remember, 3 would be days. And this right here is miles. Okay? And he wants to know the slope of the line. So that's really his speed. And it's funny because this speed is not like miles per hour, it's miles per day. So let's just figure out what that is. To do that, it's just like this one with Japan. What we do is we draw basically a slope triangle, okay? And we do the rise over the run. So that's the vertical shift over the horizontal shift. I like to write it as change in y over change in x. This triangle right here is the Greek symbol for delta, which we use for change. Just if you want to, you don't have to. It's something you'll learn later. I need change in y. Well, if this is an x and a y and an x and a y, then these two values, the 60 and the 90, are my y values. It doesn't matter which one I put first. I prefer to put the bigger one first. So I'm going to do that. I'm going to say 90 minus 60. And if I choose 90 first on the top, then I have to choose the 3 first on the bottom. So I do 3 minus 2. Okay? And then I just simplify. 90 minus 60 is 30. 3 minus 2 is 1. So that would mean that 30 miles in one day is how far he went. And we call that our rate. So, sorry, you need a little shade there on the 30. You see a 30 over 1. That's our rate. And we say the slope is the rate. And we say the slope of the line is 30. Now, I just want you to be a little bit careful here because if you have a graph that is proportional, like, let's see if I can fit this, like 1, 2, 3, 1, 2, 3, the slope of the line is always going to be kind of like this, like a 45-degree angle, or like, cutting a square in half on the diagonal. That's what the slope of this slope right here is always going to be 1. Slope equals 1. Now, the problem is when we get graphs like this, there's no way you're ever going to have a slope of a 1. If I actually drew this to scale, my slope would look like this, right? Because I go over 1 and I go up 30, right? It's going to be really almost vertical. So we squish our numbers down here and change our scale just so we can see the line. But you got to remember this line, this slope, the picture without any words is actually a slope of 1. But technically, it's still a slope of 30 because we changed the units. So be careful of the difference between a picture and a graph because when we change the units, that slope isn't actually look like it is a 1. It's not a 1, right? If you need me to explain that more, ask me in class. Okay. All right, I'm on page 129 now. There we go, page 129. Sorry about the big glare in the middle. I didn't realize I was going to have that. Another problem. The graph shows the proportions of red and blue food coloring that Taylor mixes to make purple frosting. What is the slope of the line? This is kind of a silly problem because nobody grabs a line when they're making food coloring. I mean, maybe if you had like a huge company and you wanted to make a table, actually table would be way more valuable than a graph here. But anyway, it says the number of blue drops and the number of red drops. That means number, not pound. What do you guys call it? Hashtag? This means number. Okay? So this point right here is 25, 35. And this point here is 50, 70. So it's saying for every 25 blue drops, I put in 35 red drops. So that makes them kind of purple. And if I put 50 blue drops in, I better put 70 red drops. Like if I'm making a wedding cake and I need a huge amount of frosting, I've done this before, you get a 5-gallon bucket and you fill it with frosting and it's still not enough. You might actually have to do this. I wouldn't even do drops. I would do bottles of food coloring. Anyway, we can figure out the proportion. So we still do the y2 minus y1. So I'm going to do 70 minus 35, 50 minus 25. And we're going to kind of basically find the smallest amount of food coloring ratio that we need. 75 minus 35 is 35. 50 minus 25 is 25. I can reduce that by 5s, and I get 7 over 5. So that means, which is nice, this is nice to know, for every 7 drops of blue, I need 5 drops of red, okay? What's really nice about this is, let's say, here's a great problem. This is not in your book. It just said, what is the slope of the line? The slope of the line is 7/5, and it means 7 drops to 5 drops. What's really helpful in this actually is, let's say I'm letting my kid put drops of food coloring in, and they do it, and they're like, okay, the bottle ran out, and there's only 17 drops of blue. And then you're like, oh my goodness, 17. Well, how am I going to find out how many drops of red to do, right? Well, I know it's whatever blue is, red is a little more, but I really need this to be accurate. So what you can do is you can say the number of red drops equals 7/5 the number of blue. So I can just take my number, 17, and multiply it by 7/5, and I'll probably have to round. Let's just see what I get. Calculator. 17 times 7 divided by 5, 23.8. So that means I would need 23.8 drops of red coloring. And I just hope that if I round to 24, that would be about right. Okay. Hopefully those helped explain a little bit about what slope is. Slope and direct proportionality, all of these words mean the same thing, but you basically need to find the difference and write it over as a fraction. So the slope could be 7/5. You could write this as 1.4 over 1. You could do that because 7/5 is 1.4. I wouldn't for now. Anyway, I hope you enjoyed. Bye-bye.